In this video, we are introducing the derivative. In the previous video, we came up with this formula that tells you the slope of a function at point C. Now we are rebranding this formula and calling it the derivative. But it still tells us the same thing, the slope of a curve at a point. It's just that instead of telling us the slope of the curve at point C, the derivative tells us the slope of the curve at any x value. Be aware that the process of finding the derivative of a function is called differentiation. So when you hear me talking about differentiating, you know we are talking about calculating the derivative. Also, be aware that all four of these expressions mean the derivative of f of x. So throughout your study of calculus, you're going to run into all of these formats. And even in this series, you'll see me use the different notations at different times, because sometimes it's more convenient to use one notation as opposed to another, just depending on the problem. Example 1. Find the derivative of f of x equals x to the third power plus 2x using limits. So here's the definition of derivative to refer back to. So f prime will equal the limit as delta x approaches 0. All right, so we have this part of the function right here, f at x plus delta x. That means we're going to take x plus delta x and substitute it into the function. So notice the function is x to the third power plus 2x. So I'm going to do x to the third power, but instead of x, I'm going to put parentheses. All right, and here's 2x, and I'm going to put another parentheses. So all of this is function f. Now inside, instead of having x, I'm going to put x plus delta x. That's what it means when they say f at x plus delta x. It means plug in x plus delta x into the function. All right, I'm going to need a longer fraction line. So all of this red stuff is just the box right here. Now I'm going to do the last little part, the minus f of x part. All right, so minus, and this is f of x. The function itself is f of x. So I'm just going to do minus x to the third power plus 2x. And then in the denominator, it is just delta x. So it's really just all about simplifying this down. We're going to do some calculations off to the side right now and then just substitute it back in, because one part of what we have to calculate is this, the quantity x plus delta x cubed. Now this means x plus delta x times x plus delta x times x plus delta x. So if you wanted to just FOIL this out by brute force, you could multiply these two together and FOIL that out, double distribute, however you want to call it, and then you could take that result and then multiply it by x plus delta x and do a whole bunch of distributive property. That's one way to do it. I consider that to be the long way. In a previous class, whether it was geometry or pre-calculus or algebra 2, you should have learned about Pascal's triangle, which is just really a shortcut for simplifying expressions like this. And if I think about it, I'll put a little link up in the corner to a video on Pascal's triangle, because I'm just going to go through it like super quickly right now. But Pascal's triangle was like this. It always started off 1, 1, 1, and then there was a 2 in the middle because 1 plus 1 is 2. There's always 1s on the outside. And now here comes the row that we're really going to use. 1 plus 2 is 3. Same here, and then 1s are on the outsides. Now, what does this have to do with anything? These are the coefficients for when you're doing something to the third power. These are the coefficients that you use. So the coefficients are going to be 1, and I'll just put pluses in front of everything. 1 plus 3 plus 3 plus 1. So what I do is I'm going to take the first term and I'm going to start with this power. And I'm just going to go from left to right. All right, the left term starts on the left. So I have x to the third power, and then it's just descending. So then it's x squared, and then it's x. So this is just a shortcut. Now I'm going to switch over, and now I'm going to do this guy. This is on the right, so I'm going to start on the right hand side this time. And again, I'm still doing the third power to start off with. So over here, I'm going to have delta x, which I'll put in parentheses. I'll have delta x to the third power, and then I'll have delta x squared, and then I will have delta x. All right, the last term doesn't get anything. And boom, this is it. In just 30 seconds, I simplified the expression x plus delta x to the third power, and here it is. All right, that's quicker than distributing and distributing again. So I'm just going to copy all of this back into the problem. Sorry guys, these problems do get tedious sometimes. So look, everything I've written down so far is just the cubed part only. I haven't even written down the 2 times x plus delta x part. I am going to go ahead and do the distributive property as I do that. Let me just clean that up before I go forward. So now I'm doing the distributive property. So 2 times x, of course, will be 2x, and then 2 times delta x, so plus 2 delta x. So that's all the red stuff. I'm going to need a longer line. I'm even running out of screen, man. All right, hopefully I can start canceling things out soon. I need to do the distributive property here as well. I had to put these parentheses around this expression because of the negative sign. Now I need to distribute that negative sign. So notice that the plus right here is going to turn to a minus. So I am going to have minus x to the third power, and very important, it will be minus 2x. All right, it all just barely fits on the screen. And don't forget the denominator is still good old delta x. Scan across this mess looking for things that might cancel out. Do you see anything? Well, I'm noticing that I have x to the third power right here, and then I have negative x to the third power right here. That is great. I can cancel those out because I'm tired of all of these characters. I want to get rid of some of this, clean it up a bit. Do you see anything else that I can cancel out? All right, hopefully you noticed the 2x that's right here, and I have a negative 2x right here. So those will also cancel each other out. All right, so I'm just going to recopy this and bring it down. So at this point we have f prime equals the limit as delta x approaches 0 of all of this. By the way, we would love to do direct substitution and just put 0 in for delta x, but unfortunately delta x is in the denominator, and that would cause a 0 denominator, which is undefined. If only we could get rid of that denominator somehow. Well, here's where it gets fun. Look at the numerator. Do you see a common factor that we can pull out as a GCF? Notice that every single term has a factor of delta x in it. Delta x, delta x, delta x, delta x. So delta x is a GCF. Let's pull that outside of parentheses and put it in the front. So I've factored a delta x out as a GCF, and hopefully you can follow that. If you compare what I have here in the numerator to the previous numerator, you'll see that each term is missing one of its delta x's. For example, here I had delta x cubed, and now it became squared because I took one away and put it out in the front. But of course, what I can do now is notice that I have delta x in the numerator and delta x in the denominator. So I get to cancel these out. And now I'm just going to recopy. So we are almost to the end. Now that we have no denominator, there's no problem with doing direct substitution. So I'm just going to substitute 0 for every delta x. So every term that has a delta x in it is going to go to 0, because remember, we're finding the limit as delta x approaches 0. So as delta x approaches 0, this term is going to go away, and this term is going to go away. All right, every term that had a delta x in it is going to become 0. All right, now notice, when I write the derivative this time, all right, f prime of x equals, I am not going to write the limit as delta x approaches 0. We've already done the substitution. What we get now is the limit. We've already found the limit. So the limit is 3x squared plus 2. So this is the derivative of f of x, 3x squared plus 2. Now, we did a whole bunch of calculations, and it's easy to forget what it is that we really found. Always remember, the derivative is the slope of a curve at a point. All right, I'm going to repeat that, and I want you to say it back to me. If I ask you, hey, what does the derivative tell you? You're going to say the slope of a curve at a point. So through the magic of calculus, we have come up with this formula, this derivative, that tells us the slope of the function at any x value. So let's try it out. I'm calling it example 2, but notice this is the same function from example 1. So what is the slope of f of x at the point 0, 0? So notice that what we really need from this is just the x value. All right, that's what we're going to substitute into our derivative formula. So since we have the derivative formula, we're just going to use it. So if we do f prime at 0, that's going to tell us the slope at 0. And that's going to be 3 times 0 squared plus 2. I'm just substituting 0 in right here. And that gives us, well, this term has a 0 in it, so that's gone. That's just going to leave 2. So this tells me that at the point 0, 0, at the origin, the slope of this function, this cubic function, is going to be 2. It's like magic how we figured that out. Here's a quick glimpse at the graph. So in blue, you see the function, the cubic function, and the orange line is the tangent line. And notice it fits perfectly right around 0. And notice that the slope is 2, just like we expected.